Everyone. Let's start with the permissions in Linux part 2. So in this one, we are going to see. I just want to recall that concept of octal values for permissions. Okay, so I just explained that in very vague manner. So in this one, we are going to see in the real time, like in this one. Let's see if I have something. Okay, I have student.txt over here. So I'll just say ls-ld. D is for actually the directory. So let's type this one, student.txt. Okay, so as you can see, this first hyphen or dash is for the identification of that particular what is this. So this is a file. So that's why this one is over here. The dash is representing that this student.txt is a file. If we are going to say that, I'll just show you. If ls-ld to usr, then it will say that it is a D. D means the directory. It represents that user slash is a directory. Okay. So student.txt is a file by showing dash. Okay, you can see this is the R. R means the read permission. So first three permissions is for the users. First three permissions are for the owners. Okay, then the next three permissions are for the group owners, and the last three permissions are for others. Okay, I'll just clear the screen, clear, and then now this one. Uh, student.txt. Okay. So first three permissions are for the owner of the file. Then the next three permissions are for the group owner of the file. And the last three permissions are for the others. So here we can see the owner of the file is root itself, and the group owner of the file is root. Okay, so especially in this one, we should be in the root terminal because in the next such topics, we need to see some great commands. That's why we need to be in user mode, not in the user mode, in the root mode. Okay, so let's see the first one. The read is calculated as 2 raised to 2 is equal to 4. So the permissions for the read is 4. Okay. So the read represents 2 raised to 2, which means 4. Then the write permission is equal to 2 raised to 1 is equal to 2, which means this write permission have 2 raised to 1 is equal to 2, which means this will have 1. The permission count is 1. Not the one, it's two. Sorry. Uh, the read have. I'll just stop this. Okay. How can I? Okay. The read have four, the write have two, and the execute have one. Why these octal values are used? Because the Linux can't directly communicate with the numbers. So that's why it should be communication. The communication should happen with the octal values. So that's how the Linux calculates its permissions, and then it it is a good way to understand for us how to calculate the permissions of the file or the folder. So let's see the next one. The default file permission. Okay, we'll create a new file. We do have the student.txt. We'll just create a teacher.txt. Touch teacher.txt. Okay, we'll see was the permissions of the teacher.txt. We haven't changed any of the configuration for the teacher.txt or any permissions. So let's see what's the by default permissions. So ls-ld for teacher.txt. And it is just the same read, which means 4 plus 2 is 6, and dash, which means 0. Then for the group, it only have read permission, and for other, it only have the read permissions. So 6 plus 4 plus 4. Can we see that? 644. Owner read write, group read, and others read. Okay. So we are going to see a new concept as UMASK. So UMASK is user file creation mask. Okay. So it defines default permissions for new files and directories. How can we, like, in this time when we are creating teacher.txt, we don't care about the default permissions to create the file, or which permissions would be applied on that file. Okay. But if you are in the industry and you want to manage those permissions in your, like, group or in your others environment, in the teams, so how you can manage that? So that's why the UMask concept is used. How can we say that? Okay, here is a default value of UMask. Okay, how can we see the default value? We will just say UMask. Here you can see the UMask is set on 0022. We are going to see how we can use that UMask. Example calculation for UMask. Let's see the example. If XYZ folder has permissions of read write execute, read dash execute, and dash dash dash, which means 710. We'll just create that folder. Or we'll just say mkdir, which is make directory, and xyz, xyz. Okay. And we'll say ls. Do we have that folder xyz? I'll just, yes. Here we can see XYZ folder is available. I'll just clear the screen. Okay. So let's see which permissions the XYZ have got. ls-ld xyz, and yeah, it does have read write execute, read hyphen execute, and read hyphen execute, which means read 4, write 2, and x is 1, so it would be 7. Then read is 4 and execute is 1, then it is 5 and it is also 5. So 755 is the default permission we have got. What is this? So it does have 710 permissions. Okay, don't worry. So the full permission, okay? So the full permission count is 777. How we can calculate that? If we have RWX here for the owner, RWX here for the uh, group, and RWX here for the others. How we can set that? We can say chmod 777 and for the XYZ file, XYZ folder. And we can see that ls. You can see it does have all the permissions, but it is a bad practice to give all the permissions. So let's see how we can manage the UMask. Okay, so set the UMask for 067. So for this folder, it does have 710 permission. So let's set the 710 permission. Chmod 710 for XYZ. Okay, and we'll just check that we do have 710 permissions. So let's see how we can calculate the UMask. Okay, so for this we need to do the subtraction. So what's the full here we can say what's the full permissions? It is 7, 7, and 7. Okay, for the owner, group, and others. We do have 777. We just need to subtract that 777 from this 7, 4. Oh, okay, 710. I think, yes, 710. Because it is 7, this is 1, and this is 0. So 710, we are going to subtract from 777. So what we have got at the end, we have got 067. Okay, so if you want to create new files or folders with 710 permissions, then we need to give umask as 067. Okay, so let's see how we can set the umask as 067 for further would be creating or will be creating file or folders in the futures. So let's see. We have seen that umask by using the umask, we do get a value which is the default value for now in this uh, terminal actually. So how can we set the UMASK temporarily? Okay, so if there are two ways to set the UMASK. The first one is temporary and second one is permanent. So in the temporary one, if you want to set the UMASK for this particular terminal, okay, if you close the terminal, the UMASK would be gone, okay, and the default one would be back again, okay. So let's see, set the UMASK temporarily. I'll say UMASK 027, okay, UMASK 0, 2, and 7. UMASK set, I'll just check UMASK, it is 027. Previously, it was 0022. Now it is 0027. Okay. Now we can create any file and we need to check XYZ. Now we will create ABC. mkdir file ABC and we'll say ls-ld ABC. A, B, and C. Can you see the file have permissions of 7. It does have permissions for read and execute, which is 4 plus 1 is 5, and then 0. How it does it managed to do that? By using the UMask of 0 to 7. How we can do that? If we have 777, right? And we set the UMask for 0, 2, and 7. It does have value for 750. Let's see how the 750 works. 7 is for the owner, right? 5 is for the read, then execute only. So, what's the value of read? It is 4. And what's the value of execute? It is 1. So, what's the total? It is 5. So, 7, 5, and 0. Understood? Great. So, let's, yeah, if we, this UMask, it is a temporary UMask. If we create another terminal, can we do that by pressing Control T? No. Option T? No. Control Shift. Okay. Control Shift T for the Mac. So here we have Sue Gaikawa as a user. I'll just change that to root and I'll give the password for the root, clear the screen, and I'll just say umask. And here you can see in the new terminal, the umask got the default value. But in this one, the umask have the temporary value. Got it? Now we are going to see how the U set the UMASK, how to set the UMASK permanently. Okay, so the first way is modify /etc bash rc for all the users. Let's see. We'll just say vim /etc bash rc. This is the file, and here we can say that. Can we find UMask? Yes, we can. And you just have to modify this value. So if you want to set 0 to 7, then you can go here and modify your values. Okay, this would only useful in uh like the industry where you have multiple people and you want to set the credentials or the permissions for incoming candidates or incoming interns or full-time engineers, so full-time employees. So you can set as per that. Okay, I'll just go out of this file. I'll just say quit. Okay. The next is to modify the bash rc, dot bash rc. As you have known that every user in the system or in the machine will have its own dot bash rc file. It's a hidden file. So I'll just say we does have two Gaikawa user over here. ls-a is used to list all files with the hidden files. Bash rc, yes, this one. Can you see the bash rc file? It's a hidden file. So let's see vim dot bash rc. Can you see the bash rc? Now you just have to set the UMask specifically after any of the fi. If fi is there, then you should be known to the syntax of the if-else statement in the shell scripting. So you have to put your UMask after the fi. You can put it after the path. Okay, so that's how you can set the UMask in the dot bash rc for specific user in the machine. Okay, you okay. Yes, and at the end of the file, you can add the UMask 0 to 7 at the end of the file. So UMask would be set for that particular user. So now let's see the next topic. It is a very interesting topic, I think. So the topic name is group ownership inheritance. For this topic, we need to be in the root user. So I'll just delete this terminal. There is still a process running on this terminal. Close the terminal or kill it. I think the UMask is the one. Uh, okay. What's the group ownership inheritance? Let's see this with an example. Okay. We'll create a file. The file I'll just list out. Okay. cd slash ls. We do have uh, two files, but we'll create a folder actually. Uh, okay, we'll create a folder. The folder name is ABC, and we'll give it a good name for this example, mkdir, and we'll say mm, what we can say, roll number. ls, do we have roll number? Okay. Uh, okay. group ownership inheritance. Okay. So in this one, if let's see the theory part first. If root creates slash test, in this one, can we create the slash test? Do we have the test folder? So we can go as per the Notion document. So I'll just say RMDIR forcefully the roll number. Okay. RF RMDIR help invalid option F R RMDIR hyphen R. Okay. We'll create a new folder as slash test. Okay. mkdir test. And if we say ls, we do have test folder over here. Okay. So if root creates the test folder, both owner and group will be root. How we can check that? ls hyphen l, which means the long listing, and d for the directory, and then test. We can see the permissions. Who is the owner of the folder? It is root. And who is the group owner of the folder? It is also root. Okay. So now, if the group is changed to cells, okay. So we need to do group add cells. Cells is already exist. Great. So we need to change the group as I think we can change it by using uh, group change chmod or how we can change it. I need to how to change group in Linux. chgrp. Yes. chgrp change group with sales. I'll just say help and okay option and the group file. Okay. And we can say clear chgrp for the change group sales to the test folder. Can we do that? Okay. ls hyphen ld for test. We can say that the group for the test folder is sales. Okay. So now, if I create something as a root, okay, we are doing every single operations as a root. So if I say cd test and I want to create another folder inside the test. So mkdir test one. Hmm? So what would be the owner and the group owner of test one file? Okay, so we'll see ls-ld for test one. Oh, there is a problem over here. Now the test folder have its group owner as sales, but we created a test one folder inside the test. It don't the test one don't inherit the properties of test as the sale like the group owner, because we can see the root is the owner of the folder and the root is also the owner of the group owner of the test one folder. That's the issue. This issue we want to overcome in this group ownership inheritance concept. Okay, let's see. To prevent this, SGID, set group ID bit, is used. So we can use SGID bit. Okay. So how we can add the SGID bit? We can use the octal value. Sorry. We can use the numerical value So we can say chmod. So we need to give 2 to 775 for the test folder. Not this one. We need to go outside of the, okay, now here, and we need to give chmod to 775. 5 means read and execute only for the others. And like a root can do everything. So we can say chmod 2 is for the sgid bit and the test folder. Okay, now we can see ls-ld for test folder. Can you see something in the group ownership permission? This is for the owner and this is for the group owner. Okay, so we have S as the SGID bit in the permissions. Okay, so now if we create something inside the test folder, let's go cd test, and I want to create another folder as mkdir test2. Okay, we need to see what uh, who is the group owner of this test2 now. ls-ld test2. Can you see the group owner of test2 folder is cells? So there will be consistent group owners inside the particular folder. Okay. So if the root is creating something, so it will not give group ownership to the root, but it will give the group ownership to the particular folders group ownership. It will inherit those group ownership permissions. Okay, I do think that this concept is clear. So if we want to remove the HGID bit, oh, we can use this command too. This is very like easy command. The group, and we need to add the permission for the group. So you can see the G is there and we can add the S bit. Okay. So S bit is used for the SGID bit. This is also can be used. So now we want to remove. So we'll use this one now. We have used the numerical value for adding. We'll use the next command or the second command for removing it. So we'll see cd and we'll go to this one, and ls we do have, okay, and ls hyphen ld for test. Okay, we do have the s bit over here. So we'll say chmod g means group, minus means remove the permissions for s and the test folder. Okay, now if you want to see the bit is removed. Okay, now if we create another file inside the test as test3, it will again have root as an owner and root as a group owner. Okay, so we are going to see the last concept of this lecture. So the last concept is SUID bit. SUID means super user ID bit. Okay, it allows a normal user to execute a file with root privileges. So a normal user can become root for the that particular uh, command or that particular task. Okay, only applies to binaries. Binaries means the command files. Where do we have all the command files? In the slash bin folder. The commands in the Linux. Yes, the binaries are the commands in the Linux and normal files. Okay. So the first task is find the files with SUID bit. We need to find that. This is a very popular question. So find slash means this is the one, the directory, the home directory of the root, and hyphen PERM is permissions, and 4775. 4 is the bit, specific bit for the SUID. Okay. So we'll type that find from this directory and hyphen per means permissions 4775. Okay. We'll have something as permission denied. Okay. So can we do mm, permission denied? Okay. Sudo. We are in the root, so we don't have to give the sudo. Okay. We'll try this in the normal user. Let's see. Find slash hyphen perl and the bit is 4755. 4755. Okay. Now, can you see something? So slash user slash bin mount and NFS. Okay. Now you can see some uh, binary files. Okay. Here you can see slash user slash bin slash passwd. Passwd command is used to set the password. It is a crucial command. Okay. So what do you think? Passwd command should be executed by the root, okay? Because root have those privileges. To Gaikawa, which means my username, Suyash Gaikwad username should not be changing other users' passwords, right? But if he wants to, hmm, then we can set the SUID bit as this 4755 for slash bin passwd. Let's see this command chmod 4755 chmod for 4755 and for slash bin slash passwd. Okay, slash bin slash passwd. Okay, then changing permissions for the bin operations not permitted. Why? Because I'm in the normal user, the regular user. Okay, so can we do this from the root chmod 4755 for slash bin slash passwd slash bin slash passwd. Okay, we can do that from the root. Okay, but yes, we can also use this one. Okay, but if you want to remove this, so it's like it's not recommended to remove any permissions from the SUID bit because it will like create some trouble for you. It creates some trouble for the other users in the machine. Okay, so it's just for the experimentation, but it's not recommended at all. Only for the experimentation. We can also remove the SUID bit from the particular binary file. So chmod, and we can say u from s. Okay, u from s bin slash bin slash pass wd slash bin slash pass wd. Okay, but you should not do that. So I'll just set that again. I hope that this SUID bit concept is clear to you. Now, any of the user in the uh, folder, it can use slash like the this passwd command. Okay, only root can be using this command, but now as we have set the uh, user ID bit, super user ID bit, the normal users can also be executing the particular command. Okay, so I think that's all for this lecture. Thank you.